Hello guys, welcome to my channel Why the Truth. Today, we will explore the universe of science and pseudoscience. In this few minutes journey, we'll try to understand the key differences and equip you with the tools to separate facts from fiction. Let's get started. The scientific method. Science is all about the systematic approach known as the scientific method. It's the backbone of real science. Scientific method is based upon following aspects: defining the problem, making observations, forming a hypothesis, conducting an experiment, drawing conclusions. In contrast, pseudoscience often lacks this rigor, making claims without proper testing. Science relies heavily on empirical evidence, observations, measurements, and reproducible results, whereas pseudoscience often relies on anecdotal evidence, testimonials, and personal stories, which can be misleading. Empirical evidence is crucial in science because it provides concrete, observable data that can be used to test hypotheses and theories. It serves several key purposes. Empirical evidence allows scientists to test their hypotheses by collecting real-world data. If the evidence supports the hypothesis, it lends credibility to the proposed explanation. Empirical evidence is objective and not influenced by personal beliefs or biases. It provides a common ground for scientists to evaluate and discuss their findings. Other researchers can replicate experiments or observations to verify or refute the initial results. Reproducibility strengthens the reliability of scientific conclusions. Over time, accumulating empirical evidence can lead to the refinement or revision of scientific theories. It ensures that scientific knowledge is dynamic and can adapt to new discoveries. Empirical evidence forms the foundation for evidence-based decision-making in various fields, from medicine to environmental policy. Empirical evidence enhances the credibility of scientific claims. Peer review and scrutiny from the scientific community ensure that only well-supported claims become widely accepted. Peer review is a process used in academia and scientific research to assess the quality, validity, and credibility of scholarly work, such as research papers, articles, or proposals. It involves experts in the same field peers evaluating and providing feedback on the work to ensure its accuracy, rigor, and adherence to established standards before it gets published or accepted for further advancement. Peer review helps maintain the integrity and reliability of academic and scientific publications. Peer review. Real science undergoes thorough peer review. Experts scrutinize methods, data, and conclusions. Pseudoscience claims often skip peer review, relying on biased sources or self-proclaimed experts. Falsifiability, a concept introduced by philosopher Karl Popper, is the criterion used to determine whether a scientific hypothesis or theory can be considered scientifically valid. A statement, hypothesis, or theory is considered falsifiable when it can be formulated in a way that allows it to be potentially proven false through empirical testing or observation. In other words, for a claim to be scientific, there must be a way to design experiments or gather evidence that could demonstrate it to be incorrect. Falsifiability is a key element in the scientific method as it ensures that scientific theories are subject to scrutiny and can be refined or discarded based on empirical evidence. Scientific theories are falsifiable, which means they can be proven wrong through experimentation. Pseudoscience often presents claims that are impossible to test or disprove. Consistency with established knowledge. Science builds upon established knowledge, connecting new discoveries with existing theories. Pseudoscientific claims often contradict well-established scientific principles. Critical thinking is the ability to objectively and systematically analyze, evaluate, and synthesize information or ideas to make reasoned and well-informed decisions or judgments. It involves actively questioning, examining assumptions, considering evidence, and exploring alternative viewpoints in order to arrive at logical and sound conclusions. Critical thinking is an essential skill in problem-solving, decision-making, and effective communication, as it encourages a deeper understanding of complex issues and helps individuals avoid making hasty or biased judgments. Critical thinking to tell fact from fiction. It's crucial to apply critical thinking, ask questions, seek evidence, and be skeptical of extraordinary claims. Embrace skepticism and demand evidence before accepting any scientific or pseudoscientific claim. Let's see these principles in action with real-world examples. Think of vaccines, climate change research, and space exploration. And now, let's contrast these with pseudoscientific claims like flat earth theories or miracle cures. Becoming a critical thinker. Becoming a critical thinker isn't just about spotting pseudoscience. It's about engaging with the world thoughtfully. Read, learn, and stay curious. Expand your knowledge and sharpen your critical thinking skills. We've explored the world of science and pseudoscience, armed with the scientific method, empirical evidence, peer review, falsifiability, consistency with established knowledge, and critical thinking. You're better equipped to navigate the sea of information and separate facts from fiction. Remember, critical thinking isn't just a tool, it's a way of life. Stay curious, stay skeptical, and always seek the truth based on credible evidence.